Hi everyone, and welcome to the Science in Space panel. So we have some wonderful panelists here today, and we're going to be talking to you about our journeys into the space sector. They may not have all started there, and how we got going. So just to give you a brief introduction to our panelists, we have Catherine Riggin, who's a PhD student in planetary science at the Mullard Space Science Laboratory at UCL. We have Dr. Tamlin Peel, who's a teaching fellow in remote medicine at Imperial College London. We have Dr. Claire Cousins, who's a reader in Earth and Environmental Sciences at the University of St Andrews. And I'm Meganne Christian. I'm a reserve astronaut with the European Space Agency and exploration commercialization lead at the UK Space Agency. So before I ask our panelists to give an introduction to themselves, I'll just give you my story of how I ended up where I am today. So just sharing my screen. These are some photos of a year that I spent in the darkness, the polar night of Antarctica. We'll get into that in a moment. But first of all, just a background on me. So I was born in the UK. But you may hear from my funny accent that I didn't grow up here. I grew up in Australia, went to the Illawarra Grammar School, and I went to the University of New South Wales doing a Bachelor of Engineering and a PhD in industrial chemistry. Then after that, I was looking for a postdoc, and I wanted to do that in Europe. And so I found a postdoc at the National Research Council of Italy in Bologna. And so I was there for what was supposed to be a 1 to 2 year postdoc, but actually ended up being for 9 years. I got a permanent job there. But then a few other things happened that brought me back to the UK. So this was me back when I was about 11 or 12 years old in the top picture there. I was always the smallest person in my year. So you can see I was sitting on the end of the front. By year 12, I got a little bit taller, but not much. Every day when I was at school, I kind of changed my mind about what I wanted to do with my life. But I knew that I wanted to do something big, exciting, and unique. So there's a quote there, I haven't been everywhere, but it's on my list. I really enjoyed traveling and I wanted to see the world. And I also had a strong sense of love and protection for our planet. So I wanted to do something that helped our environment. So when I got to the end of school, as I said, I was kind of changing my mind all the time about what I wanted to do. But in the end, I decided to do a Bachelor of Engineering in Industrial Chemistry, which is kind of a good combination of both sciences and engineering. And during that, I had what was called a co-op scholarship, which meant that I got to do some industrial training placements as well. So one was at a water treatment plant, one was at a chemical plant making filtration membranes, and the last one was at BlueScope Steel making coatings for steel roofs. I really enjoyed those industrial training placements, but in the end, I decided I wanted to stay in research because I like sort of to challenge myself every day, and that's what you tend to do in a career in research. And so I continued on and I did a PhD. That's the title of my thesis there. Just in kind of more rough terms, I was working on materials for hydrogen storage, so for fuel cell vehicles. We have a lot of electric cars nowadays. We have some hydrogen cars, but one of the difficulties there is how you store the hydrogen. So that's what I was working on. Then I moved to Italy, as I said, and I was working at the National Research Council. I was still working on nanomaterials, but not on hydrogen storage anymore. I was working on a material called graphene, still for sort of alternative energy applications, but I also got to do some space applications work as well. And that was my first taste of weightlessness. So the materials that I was making were for thermal management on satellites. And so these have to be able to work in conditions of weightlessness when you don't have gravity. And so I had to go up there and test these materials. And I did this on a parabolic flight, otherwise called a vomit comet. And that's for a good reason, because it does this maneuver where it goes up very steeply and then comes down steeply. And during that time, the top of that parabola, you have about 22 seconds of microgravity, so you can test your materials during that time. On either side, you have double gravity. So this constant changing between feeling very heavy and feeling very light tends to upset your stomach a little bit. Now, during my time at the National Research Council, I also spent a year at Concordia Station in Antarctica. I didn't know it wasn't the kind of work that I was doing before. This is natural sciences, the kind of sciences that you can see up in the corner there. Um, but I got to go there because I had these transferable skills from being able to work with scientific instruments. And I had always been fascinated by Antarctica from when I was about your age, and when I went to a museum which told me all about Antarctica, and it kind of stuck there at the back of my mind. I didn't think that I would actually get to go there, but the opportunity came up and I took it. So I got to stay at this amazing place. We got down to about minus 80 degrees Celsius, and with wind chill, our coldest day was minus 104 degrees Celsius. I was working outside every day. I was launching weather balloons. I was looking after scientific instruments looking into climate change. And the other difficult things were 100 days of complete darkness where the sun didn't rise. The fact that we were at high altitude, so the atmospheric pressure was a lot lower than what we have at sea level. So it's harder to breathe, especially when you have to climb lots of stairs. And also the humidity was really low because the atmosphere just can't hold that much water when the temperature is so low. So that makes it difficult on your body. And it's also difficult on your mind because you're in a small group, just 13 people for that winter period. You can't escape if something goes wrong. So you really have to rely on each other. The reason that this location was chosen was for a project called European Project for Ice Coring in Antarctica. They drilled this ice core and cut it into little slices. And you can see in these slices that there are air bubbles. And they could correlate the depth of this slice with the period in history. And they could analyze the gases that were inside these air bubbles to tell us the composition of the atmosphere going back 800,000 years. And that's where we have this famous graphic which tells us that the amount of carbon dioxide and methane in our air has increased so much in the past 100 years due to human activity. There's now a project called Beyond Epica, and I got to visit the second time I went to Antarctica, that is going to drill an ice core going back 1.5 million years to give us even more information about this. But it was my time in Antarctica that led me to apply to become an astronaut with the European Space Agency, because the work that I was doing there, running other people's experiments that they had put their life's work into, but couldn't be there themselves to be the hands, is a lot like what astronauts do on the International Space Station. So after going through a rigorous process that I talked about this morning, I was finally selected as one of the class of 17. I'm a reserve astronaut, so that means that I continue with my job. That was at the National Research Council of Italy, but as I said, a few things happened. I wanted to get more into the space sector, so I came to work for the UK Space Agency. And so thinking about the future of human space exploration, whether that's the International Space Station or the commercial space stations that will come afterwards, the Artemis missions to the moon, we're going to build a station orbiting the moon and one day have stations on the moon as well, and the robotic missions going to Mars. So it's a lot of really exciting stuff. And I'm so happy that that I get to be in the space sector. But I had a kind of funny way into it. So I haven't always been in space, but I'm really enjoying what I'm doing. So I'm going to hand over to our other panelists now. First of all, to Catherine Regan, as I said, a PhD student in planetary science. So she's going to talk about her journey into the space sector.
Thank you so much. Hi, everybody. So my name's Catherine and I'm a PhD student. So this means I am still studying, I'm still in education, but it is still a job. But at the end of my PhD, I will hopefully become Dr. Regan, and I research Mars. But I had a bit of an indirect route into studying Mars. So when I was at school, I was told I wasn't clever enough to do physics and space. And I unfortunately believed this for quite a while. So I didn't come into space immediately. But I really loved education. I really loved learning, and I wanted to continue this with whatever I did. So I went to university. I went to the University of East Anglia up in Norwich in 2016, and I did my undergraduate in environmental geophysics, which sounds like a mouthful, but it isn't. So what I was researching was the maths behind events on Earth, like volcanic eruptions and earthquakes and tsunamis, and learning the kind of maths and science behind these events on Earth. Now, I really, really enjoyed this. And I had a really fantastic supervisor, and I had a meeting with her and said, I'm finding all of this really interesting, but I'm still really interested in space, but I know I'm not qualified to go into space, so I'm not really sure what to do. Now, she gave me some really fantastic advice, which kickstarted my career and said, you are experienced, you've done volcanoes on Earth, why don't you do volcanoes on Mars? So hopefully my screen is sharing and you can see this. So that's what I did. I started learning about Martian volcanoes. So I took all of the experience that I learned about Earth and just took it to a different planet. And I did a research project on Olympus Mons, which is this volcano here, which is the biggest volcano we found so far in the solar system, which is on Mars. So I did a research project on this, absolutely loved it, and decided I really wanted to stay in the field of research with a focus on Mars. So after my undergraduate, I decided to leave and move to a different university for a master's degree. So I did a master's degree in planetary sciences at University College London. And there I started working with the Mars Express satellite, which is here on the left. I did a research project using data from that satellite and decided that this was for me and applied to do a PhD at the Millard Space Science Laboratory. So the Millard Space Science Laboratory is part of University College London, but we're out in the remote fields in Surrey. So we're not based in central London. So I've been there for the past 3 years and I've now only got a few months left to finish up my thesis. And I still now work with Mars Express, but I also work with the MAVEN satellite, which is the one on the right. So I use a combination of data from both of these satellites to investigate what's happening in the space surrounding Mars. So this is called the plasma environment. So plasma fills space, it's constantly being emitted by the sun. And I look at how this plasma interacts with Mars during big weather events, which are called global scale dust storms. So at Mars, every year there is a dust season, like we have a hurricane season here on Earth. And there are dust storms kind of regionally across Mars. But every now and again, it doesn't always happen, these storms merge into a global storm where the entire surface is covered in one singular storm system. Now, these are huge events. You can see visually the impact they have on the surface. It really obstructs our view. And I'm researching how this impacts the space surrounding Mars. So I'm looking at the magnetic field and looking at the plasma to see how their behavior is changing when these events happen. So this photo is from the 2001 global scale dust storm, and there have been two since then, one in 2007 and one in 2018. And those are the two storms I'm looking at. So at the moment, I've finished my initial research and I'm writing it all up into my thesis, which will be a book composing all of my research. And I will then defend that to become Dr. Regan, hopefully in a few months. So that's the current stuff I'm working on. But what's really exciting is that I have the opportunity to work on upcoming space missions as well. So I'm going to talk about 3 of the missions that I'm involved in that are launching soon. So the first one is an American mission called Escapade. This is a 2-satellite mission that is launching to Mars this autumn, so not very far away. And this is going to be looking at the space environment of Mars. So similar to what I'm researching, but looking at the interaction of the solar wind with the planet. And I get to go to the launch in September, which I'm very, very excited about. So this will be launching very, very soon. Now, a little bit further away in the future, in 2028, the Rosalind Franklin rover will be launching. Now, this has been in the works for a long, long time, but I'm involved in the camera at the very, very top, which is called PanCam. So I'm part of the science team for PanCam. Now, this will be launching in 2028 with a hopeful landing onto the surface in 2030. So that's something to look forward to as well. I feel very excited to be part of that team. And then the final mission that I'm involved with is a proposed mission. So it hasn't quite been accepted to go through yet. It's still in development, but it's called Matisse. And this is another dual satellite mission that's going to Mars to look at the space environment as well. And this is being led by scientists and engineers in the UK. So not only am I working with current missions such as Mars Express and MAVEN, I also get to be involved in future missions such as Escapade, Rosalind Franklin and Matisse, which is super exciting. So for quite an early career researcher to be involved in so many Mars missions is fantastic and I absolutely love it.
That is really, really exciting. Thank you, Catherine. Both exciting for the missions and also exciting to be able to be called Doctor soon. Looking forward to that. So I'm going to pass on to Tamlin now. Let's hear his story.
Hi, so my name's Tamlin, has been introduced. I'm a teacher at a university, so Imperial College in London. And I just wanted to start with this little picture that I drew when I was about 4. So I was always into science, clearly. I've got myself looking down a microscope, studying a leaf. I didn't quite go looking into leaves, but I do like to always come back to this just to think where I've come from that small child. But excuse me. but I think, like a lot of people, I grew up watching things like Star Trek and looking at photos from the Hubble telescope. There was lots of exciting things about space and science. It was a very exciting time, and now we've got lots of other things coming through. However, as someone's mentioned in one of the questions, I wasn't that great at maths. I didn't particularly enjoy it. So although I did kind of want to do astrophysics, I actually eventually got convinced not to do it. And instead, I went on to study immunology. So immunology is the study of things like vaccines and infections and how your immune system fights off disease and also sometimes goes wrong. And I went off to do a PhD eventually in doing that. So I did things like taking photos and these videos of cells running around. So this is inside a lymph node. So this is what swells up when you're sick, and looking at the different kinds of cells in there and how they move. So unfortunately, that did actually involve some maths at some stage about calculating angles in 3D space. So I had to get a friend of mine that's a maths teacher to explain it to me. But it was useful. It became useful. So I think eventually maths does kind of creep in sometimes, and you do learn it there rather than being an abstract thing. But I quite enjoyed doing that. I quite enjoyed doing the things like taking these images, doing research about asthma and infections and all the things I did. But I found that I was quite enjoyed explaining things and having people ask questions and exploring with them was almost more satisfying than doing this nitty-gritty day-to-day stuff. So I eventually became what's called a teaching fellow. So I moved from sometimes teaching, doing lots of research, to just teaching and doing research kind of to help students. So I also quite enjoyed exploring things. So I've been on a few expeditions. So I've been to the Himalayas and places like that, the high mountains. And I managed to get a job at Imperial College teaching medical students about how to act in these environments. So it's called remote medicine. So everything basically that we deal with in a remote environment. This is everything outside of a big hospital. And I do things like I take students walking in the outdoors. So we go to South Wales and take students outside to start thinking about what they would do with someone that got hurt in those environments, or how we might measure things. But we really teach them all about things. So as Megan mentioned about going to altitude, there's less air up there. So what do we do when there's less air in these environments in terms of doing things? So this is just a video of some of our students. They're doing what's called the CPR, which is those chest compressions you do to someone that's had a heart attack. And these students are in that tent, and that tent's got less oxygen in it, and they're looking at what happens when you're trying to do these things in these low oxygen environments. The other thing with things like CPR is if you then try and do that in space, these guys are on Earth in gravity. They can push down on that casualty. In space, if you were to do that floating around, that person would just float the other direction. You wouldn't be able to do anything effectively. So one of the areas that we sometimes have students looking at, and we do some stuff with, is think about how you would actually give effective CPR like this in space when there's no gravity and there's nothing to push against, unless you strap them down to something. Other things we do is talk about space. So, there's big problems with up mountains where there's less air. We talk about going down into the sea where it's cold and it's dark. And we also talk about space because lots of things go wrong with humans in space, with that lack of gravity, with that the amount of radiation out there, with the fact that it can be quite cold or quite hot. And this is just a really nice example of all the bits of your body that can go wrong in space. So your kidneys and your joints and your eyes and your hearts, and everything changes in that environment. So what I do is talk to students, medical students, about what happens in these and what we can do really to prevent these things happening. And we have students do projects at the end of their course with us, and so they start looking at some of these questions. So this is a nice picture of one of the Apollo 17 astronauts, and he's covered in what's called lunar regolith, or we would just call that moon dust. And it's a similar problem with Mars as well, because there's so little water. All this dust is very dusty and it gets everywhere, and one of the places it gets is inside your lungs. So you can see here it's all over the spacesuit, it's all over the interior of the cabin, and he's going to be breathing this stuff in. And some of our students do projects looking at what the problems are with this. So this is clearly or potentially going to be a problem for your lungs. We have this with a lot with things with miners, etc. And so students do projects looking at this kind of issues with space and medicine, and how we look after people in these environments. And this is just a slide from one of our prior students looking at how we deal with this lunar dust, this moon dust. And one of the issues is you've got to filter out the habitats to make sure that people aren't breathing it in and they're not getting infected, especially when we go back and live more permanently on the moon and onto Mars. So one of the things that needs to be recyclable, we looked at things like making out of organic material like loofahs, and the student with some engineers built a test jig to be able to do that. So this is on the right is some of the test jig to practice filtering this dust, and on the left is one of our students, Lucy, who was doing this project this year. The stuff on the right was done by another student called Connor, who managed to take this onto the Vomit Comet that was mentioned before, so that parabolic flight. So actually look at how these filters operate when there's no gravity, because it's going to change quite differently how everything behaves. And he's now just got a job with the European Space Agency to look after people that go into space. So so really what I do now is help medical students to think about space and think about how things work in space, which leads them on to potentially think about how they do medicine just on the ground, but also potentially going into careers looking after people that go into space, because this is a massively growing industry at the time. So that's all my slides for you, but thank you very much for any questions that are coming in. So I'm really excited to answer them.
Thanks so much. Yes, we do have a lot of questions coming in on the chat, so we'll see if we can get around to answering them, but fascinating stuff. And now we're going to move to Claire to tell us about her background.
Great, thank you so much. This has all been so fascinating so far. I hope you've got a good flavour of already the variety of things that everyone does. So I'm completely different again. So I'm a geologist by training. That's how I started my academic life. I'm currently now an academic at the University of St Andrews in Scotland, and I'm also in earth sciences here as well. So that's kind of been the core of what I've done for my whole career. And being a geologist, I like to, of course, look at the natural environment and the world around us, and particularly rock formations and how we can use these to further our understanding and exploration of our own solar system. Because, of course, even though it's space, which often people think is the realm of physics and astrophysics or astronomy, of course, a lot of places in space are very rocky. And so we need geologists as well to help us understand these worlds. And so the kind of research I do is what we call analog research. So this is using a whole variety of places across the Earth, all kinds of beautiful, wonderful places. We've seen wonderful examples already of the kinds of places people can go, like in Antarctica. I've been doing a lot of work over my career in places like Iceland and Svalbard. And, we use these places because they have similarities, for example, with the kinds of geological processes like volcanism that happen, as well as active environments where a sort of extremophile life can live. And we use these as a sort of a model to help us test ideas, run experiments that we can then apply directly to other places in our solar system, like Mars, or icy moons like Europa and Enceladus. To help us then design the kinds of instruments that can go up on missions, and also help us interpret data that comes back from space as well. So really, I'm a planetary scientist, but I ultimately still work on Earth. I don't actually look at any space data itself yet, but it's all about applying that to our understanding of places that are beyond Earth. So to go through sort of my story and my journey to what brought me at this desk here today speaking to you. As I said, I started my life as a geologist, but academia and research was never really part of my plan. I didn't really have a plan. I just enjoyed learning what I did about the Earth. I was always very interested in the natural world and science in general. I think that's something we can all kind of sort of attest to, just our fascination with the world in general. But through doing my undergraduate, and I was never especially a top student or anything. I never really considered myself as someone that would ever do a PhD. But going from sort of just middle of the road student, I did a opportunistic research project in my third year, my final year at university. And that's really what changed essentially my whole life. I had a great time doing this research project. I was looking at how microorganisms that live in geothermal hot springs can get captured in mineral deposits, and then how that can help us look for life on icy moons and on Mars. And I just had a great time with this. I did really well. I got the best grade I got for anything in my entire university experience. And this kind of showed me actually that getting into research and science in general doesn't necessarily have to be all about getting the top grades. It's often about just thinking of ideas, making connections that other people haven't thought about, kind of channeling your inner creativity, rather than necessarily just being good at exams or whatever. So there's lots of different skills that really come into it. And that's kind of what brought me here today. And I think what we can see from all of this as well is planetary science is a bit of a mixed bag of interests. I feel like it's the natural home for those of us that kind of either can't decide what we want to do or basically find everything interesting. And you get to do a little bit of everything. So even though I'm a geologist, I get to work with microorganisms, so I get to interact with biology. That's through understanding how a planet can be habitable, why we have places like hot springs on Earth that can be colonized by all kinds of weird and wonderful single-celled microbial life forms, and then what that can tell us about the prospects for finding life elsewhere, particularly places like Mars. All the way through to working with engineers and physicists, through working on instrumentation for space missions. Catherine mentioned the European Space Agency ExoMars rover. I'm also involved in that mission, also involved on the cameras as well on that rover. So again, that's all using knowledge of geology, of looking for the kinds of rocks that were laying down in environments that would have been sort of suitable for life, perhaps 3 or 4 billion years ago on Mars. How we can identify those rocks using these cameras on a rover. Basically being robotic field geologists to all of us back here on home, back on Earth. And working with engineers as well as working with biologists and physicists. You get a real mixed bag of people that you get to interact with, and I think that's just one of the best things about working in space. There's never a dull moment. It's always really interesting. So yeah, I'm absolutely happy to answer any questions about any of that going forward.
Thank you so much, Claire. I love that we've had this beautiful range of different careers, just to show you that the space sector is actually really broad. We've had a lot of questions coming in, so we're not going to be able to answer them all, but a lot of them are sort of around the themes of how do you get into the space sector? Is it difficult? And what is your favorite part of your job now that you're doing it? So Claire, I think you've already talked about this just now, but do you have anything to add on those points?
I think it's, never assume that, a door is closed to you. I think it's to get into academia specifically, you do have to, generally do a PhD. But it's not just a case that, if you do your undergraduate degree and, you get to that end point, that if you don't necessarily get something straight away, keep trying at it. It's not always a linear thing. You can go off and do all kinds of interesting experiences, working in industry, working in education and so forth, and you can absolutely come back to it as well. So I think it's, if you have an idea in your mind and also understanding that idea might change, like I said, I never planned on getting into academia. It sort of more found me than the other way around. Just keeping your eyes open for opportunities, really, and just following what you find interesting.
Yeah, I would absolutely agree. Just look out for those opportunities that might not seem like they're on your traditional career path, but they're out there and they'll enrich your life. Tamlin, do you have anything to add there?
I mean, I took time out from my undergraduate, and then I did eventually come back to do a PhD. So it wasn't the plan I had for my career. I think it just ended up being something that I did. I think following the things you're interested in, I think, is well worth doing. And if opportunities come around, with a lot of doctors, medics, they don't spend their full time in space. They do it as part of other roles in their job. So there's always opportunities to step in and out of things that you really enjoy and to keep going with it. So yeah, I think it's. Don't be too disheartened if it doesn't happen straight away.
Absolutely. There are lots of ways into it. There's not just the one path. Catherine?
Yeah, I think all the points raised are what I was going to say. The only thing I would add is that you might not necessarily know what it is you want to do for a career, but just following what you enjoy is the best way to find that out. So I didn't think I was going to go into space. I didn't know what I wanted to do with my career, but from kind of doing things at school and at university, I realized what I liked and what I didn't like. And just by following what I really enjoyed doing day to day, I've ended up researching Mars. So it's always a really good thing when you get paid to do what you love.
Absolutely, love that. So unfortunately, we're going to have to wrap up now. The next session is going to be technology in space. So hang around for that. You don't need to do anything, just stay at the same link and see our next panelists. Thank you so much for joining us. Thank you to all of our panelists, and thank you for listening.